In the last episode, we learned that computers store everything as zeros and ones. So let's just start from where we left off. Take a look at the left side. All that's entering the processor is a stream of binary bits, nothing more than just a long sequence of zeros and ones. By the way, if you're new here, hi, I'm Sanjana and welcome to Systems Explain, where we simplify complex computer science concepts through easy to understand videos. Coming back to the video, now look at the center. Somehow, the CPU takes that stream of bits and turns it into real actions. And the result is what you see on the right. A document opens, a game starts running, or a browser loads a web page. But here's the real question. If the CPU only sees zeros and ones, how does it know whether it's supposed to open a browser, play music, or add two numbers? That's exactly what we're going to see in this video. Now, take a look at the left side. All we have is a sequence of zeros and ones, right? It's just a pattern of binary bits. The CPU can't simply look at it and guess what it's supposed to do. Now, take a look at the right side. This is where the instruction set comes into the picture. Think of it as the CPU's built-in rulebook. The processor compares the incoming binary pattern with this rulebook. As soon as it finds a match, it knows exactly what action that pattern represents. It does not guess, but it simply follows the rules that were already built into it. But what do these rules actually look like? Let's take a look at some real examples. Now that we know the CPU follows a set of rules, let's see what those rules actually look like. Each binary pattern is mapped to a specific instruction that the CPU already understands. For example, the pattern tells the CPU to add numbers. The other one tells it to read data from the memory. Another one tells it to write data back into the memory. And the last one tells it to jump to another instruction in the program. These are just a few examples, but modern processor supports hundreds of different instructions, each represented by its own binary pattern. The important thing to remember is that every instruction has a predefined meaning. The CPU doesn't create these meanings while your program is running. It simply recognizes the pattern and knows exactly what action to perform. But recognizing an instruction is just half the job, right? But now, how does the CPU actually execute it is the question. Till here, we have learned that the CPU can recognize an instruction. But we also know that just recognizing it isn't enough. The CPU has to carry out that instruction. To do that, it follows the same three-step process every single time. Firstly, it fetches the instruction from the memory. Then it decodes the instruction to understand what it is exactly supposed to do. And then finally, it executes the required operation. Whether it's just adding two numbers, reading data from the memory, or jumping to another instruction, every operation goes through this exact three-step same cycle. Okay? And once that's done, the CPU immediately starts again with the next instruction. This cycle repeats billions of times every single second, allowing your computer to run different applications smoothly without you actually noticing what's happening behind the scenes. Right? Now let us look at these three steps one after one. Okay. Let's start with the first step, the fetch operation. As you can see, all the program's instructions are stored in the system RAM. The CPU begins by reading the next instruction from the memory. Notice that it does not load the entire program at once. It fetches one instruction at a time. Once the instruction reaches the processor, the fetch stage is complete. Now the CPU has the instruction, but it still does not know what action to perform. So the next step is to decode it. Now look at the slide. The second step is decode. Take a look at the left side. The CPU has already fetched the binary instructions from the RAM, right? But at this point, it still just a sequence of zeros and ones. So the CPU compares that binary pattern with its built-in instruction set. As you can see on the right, once it finds a match, it immediately understands what the instruction means. In this example, the binary pattern translates to the add instruction. Notice that the CPU still hasn't added any numbers. At this stage, it has only identified the operation it needs to perform. Right? The actual work happens in the final step, which is the execute step. We'll be seeing that in the next slide. Now, we finally reach the final step, which is the execution. At this point, the CPU has already decoded the instruction. It knows exactly what it's supposed to do. Now, all that is left is to perform an action. In this example, the instruction is add, so the CPU simply adds the two values together and produces the result. But we also need to remember that not every instruction is a calculation, right? Sometimes it can be reading data from the memory, writing the data back into the memory, or it might just jump to another instruction somewhere else in the program. But whatever the instruction is, this is the stage where the CPU actually performs a requested operation. Once that is done, it immediately goes back to the beginning and fetches the next instruction. Take a look at the diagram. This isn't something the CPU does just once. It follows the same 3 steps for every single instruction. First, it fetches the instruction from the memory. Then it decodes it to understand what it means. And then finally, it executes the required action. The moment one instruction is done and it's completely finished, the CPU immediately moves on to the next one, as we already know. Instruction after instruction, again and again, this keeps happening. Okay, the cycle doesn't stop. As I told you, modern day processors repeat this process for millions of times every other second. Now, here's another interesting thing. We saw opening a browser, playing a game, or using any other, for example, an AI application. Everything relies on the same cycle. This is what you need to understand. Okay, now let's look at the bigger picture. Whether you're opening a browser, listening to music, playing a game, or anything else, everything and every one of them depend on the same processor. And no matter what software you're running, the CPU always follows the same exact process. Fetch, decode, execute, and this repeats for millions of times. And that's how the CPU transforms a single stream of zeros and ones into everything you do on a computer. Finally, now that we understood how CPU understands zeros and ones, it continuously fetches, decodes, and executes. But if you take a look at the left side, you'll notice something interesting. The CPU has to keep reading instructions from the RAM. And the problem is, the CPU is very fast, but RAM is much slower, as we all know. So, why doesn't the processor spend most of its time waiting for memory? That's exactly the question we'll answer in the next episode. We'll explore CPU cache and how it keeps the processor supplied with data fast enough to execute these instructions every second. Right? Until then, thanks for watching Systems Explained. I'll see you in the next video. Bye.